Hey everyone, welcome back to the Explainer for AI and Cloud Weekly. I'm your host, and today, we are breaking down a week that has fundamentally rewired the tech world. Seriously, forget the experimental chatbots and neat little party tricks. Today, we're talking about the exact moment AI officially became the bedrock of global computing.
I want you to keep one core question in the back of your mind as we go through today's explainer. What actually happens when AI becomes the world's most critical infrastructure? Because, from data centers to operating systems to cybersecurity, AI just isn't a layer on top anymore. It is the foundation.
All right, let's dive right into Section 1, the AI infrastructure era, focusing on geopolitics and unprecedented scale. To really understand this massive shift, we first have to look at the sheer financial weight that's turning AI into a critical national asset.
Just look at this number, $295 billion. That is more than the GDP of a lot of countries. According to a recent report, China is preparing this massive 5-year push to build a nationwide network of interconnected AI data centers. We're not just talking about isolated server farms here. This is an all-out infrastructure race. They are treating AI compute like a national power grid or a massive railway system.
And to match that massive physical hardware, the software side is just exploding. 2 million tokens. That's the staggering capacity targeted for Google's upcoming Gemini 3.5 Pro model. To put that into perspective, actually, think of it this way. A context window that large is basically like handing the AI hundreds of thick books and having it instantly memorize every single word to use in its working memory, all at once. It's wild.
Which brings us to Section 2, local versus cloud agents, and the two paths of AI's evolution. Let's look at how this raw, mind-bending scale translates into how you and I actually interact with the tech on a daily basis.
We're currently watching the industry split down two incredibly powerful but totally opposite paths. In one corner, you have Google's centralized agentic data cloud. They are pulling massive amounts of enterprise data into one centralized place so AI agents can perform these incredibly complex analytics. But in the other corner, you have NVIDIA and Microsoft, and they're completely reinventing the Windows PC, aiming to put a frontier AI agent directly onto your personal laptop. But to make that local, on-device path a reality, you need an absolutely absurd amount of power. Well, NVIDIA just unveiled their new RTX Spark Superchip, bringing 1 petaflop of AI compute to slim Windows laptops. Just a few years ago, a petaflop required a literal room-sized supercomputer. Now, that same power is sitting right there in your backpack, powering your personal AI teammate. Of course, having a supercomputer sitting on your desk raises a huge question, right? How do you keep your personal files secure? Enter NVIDIA OpenShell. Think of it as your own private digital bouncer. It's a secure runtime layer that lets your personal AI agent execute tasks locally across your apps without ever leaking your sensitive data back to the cloud. You set the policy, and your data stays locked down on your machine. Moving right along to Section 3, real-world AI applications, moving from a tool to a teammate. Let's step out of the data centers and off the silicon for a second and look at how creators and enterprises are actively applying this infrastructure right now. The daily workflow as we know it is entirely changing. For all you creators out there, Adobe is completely re-architecting Premiere and Photoshop from the ground up just to take advantage of that RTX Spark chip. You can even generate 4K AI video entirely locally using apps like Comfy UI. And on the enterprise side, Google's BigQuery now features autonomous agents that can literally write complex data pipelines from scratch, making analytics up to 200 times faster. AI is absolutely no longer just a tool, it's an active teammate. All right, Section 4, the cybersecurity divide, looking at Anthropic's dual release strategy. Because as you can imagine, this immense power has a much darker edge to it. When models become this capable, they also become incredibly dangerous if they fall into the wrong hands.
Anthropic did something highly unusual here. They took one underlying frontier model and literally split it into two entirely different products. The general public gets Claude Fable 5, which is heavily restricted for safety. But vetted cyber defenders and critical infrastructure operators, they get Claude Mythos 5, where the safety training wheels are completely taken off.
So how do they actually protect that public-facing model? It's this fascinating handoff system. If someone asks Fable 5 for a malicious cyber exploit, a completely separate AI classifier flags it. But instead of just refusing the prompt, the system securely hands the request off to a much weaker, older model, Claude Opus 4.8, to handle the answer. It effectively quarantines those dangerous capabilities away from the general public.
Why go through all this complex handoff trouble? Well, because of zero-day vulnerabilities. In testing, the unrestricted Mythos model autonomously exploited 0 days in every major operating system. It even cracked a 27-year-old bug in OpenBSD that human developers had missed for decades. Let that sink in. An AI that can just relentlessly grind through code and find 0 days while you sleep is a massive, massive paradigm shift.
Which brings us to Section 5, Rules and Geopolitics, looking at bottlenecks and global guardrails. Because, quite frankly, the technology is now moving far faster than humans can possibly keep up with.
There's a quote from Anthropic's testing that perfectly summarizes this wild new reality. Their model found over 10,000 critical bugs in vital software in a matter of weeks. The terrifying part, human open source maintainers simply cannot write and deploy patches that fast. The bottleneck isn't finding the bug anymore, it's the human speed limit. And that gap between finding the bug and fixing it is exactly where attackers live. Because of systemic risks exactly like this, governments are scrambling to build the tracks while the train is already moving. The European Union is really pioneering this with their new AI Act, taking direct aim at general-purpose AI, or GPAI. These are the highly capable foundational models we've been talking about, and the EU is laying down strict new transparency laws to control them before they get embedded into literally everything.
If you look at their enforcement timeline, it's a very proactive, risk-based rollout. Unacceptable AI practices were already banned back in February. Then, the rules for those powerful GPI models hit in August 2025. And as we roll into 2027 and 2028, we're going to see strict, hardline rules applied to high-risk systems embedded in things like critical infrastructure, law enforcement, and physical products.
Finally, Section 6, the verdict and what's next. The new foundation of global computing. Let's bring all of this together, guys, because whether we're talking about silicon, software, or international law, the verdict is absolutely clear. So to wrap up what has frankly been a historic week, we are actively watching a $295 billion infrastructure race unfold globally. Google is scaling cloud memory to an insane 2 million tokens, all while NVIDIA casually drops a petaflop compute right onto your local desk. Anthropic is out here literally splitting its AI brains in half to prevent cyber meltdowns, and the EU is locking in the legal guardrails for the whole shebang. We are witnessing a fundamental rewiring of our entire tech ecosystem.
Which leaves us with this final lingering thought. If AI can discover critical exploits faster than human developers can patch them, and computing power scales to supercomputer levels right there on your laptop, who really controls the infrastructure of tomorrow? It is a fascinating and, slightly terrifying question. Thank you so much for joining me for this explainer. If you found this breakdown helpful, be sure to like, subscribe, and drop your thoughts in the comments below for AI and cloud computing. See you guys next time.